Hello, it's Keith here, and this is lesson 17 of the Suck Hunt series of Z80 programming tutorials. We're looking at more of the code of my little Suck Hunt game. So today we're going to be going over the introduction sequence, which you just saw. We're going to discuss how that's been coded up. We're going to have a look at the palettes as well, and we're just going to very quickly discuss the interrupt handler and the music. There's not much we're going to go into here. Anyway, let's go over to the source code and let's take a look. So, as I say, we're going to very quickly discuss the music. Now, the music is played via Arcos Tracker version 1. I know version 2 is out, but I still use version 1. And I have a modified version which I've added extra functionality to so that it can emulate AY on a few systems that can't support it, which is why I haven't upgraded yet. So the Arcos Tracker, the version I use is hard-coded to run music from a single memory address. And so what I do is I transfer the music I want to play to that memory address. So basically you can see that transfer going on here. And the music position I'm using on this version is F800 here, which is at the top of the memory range. Now that bank, the 8002 quadruple F range, is the video, the screen memory, but that's a spare area of that. So that's why I'm using that address. So that's our music, and then we've got our interrupt handler. I'm using interrupt mode 1. That's why I'm paging in the video to the top memory area so that we can use interrupt mode 1, which is a lot easier than interrupt mode 2. Basically, Arcos Tracker uses every single register under the sun, so there's no point using shadow registers. It simply won't work. So we're pushing all of the registers onto the stack, and then we're executing the player, and then we're restoring them all and returning from our interrupt. So that's how the music is done. Now, the introduction itself, basically what we've got is we've got a series of animations, and these animations are miniature tile maps. So what we've got is we've got a bank of different tile maps, and you can see them here. These are the tile maps. So there are basically 2 frames for each section of the introduction, and there's 4 sections for the different corners of the screen. And these are defined in an introduction sequence here. So you can see we've got an X and a Y position, and we've got a color, and then we've got a pair of pointers to those tile maps. And so those tile maps are being used to draw the graphics to the screen. Now, these are represented in our code here. You can see first we fade out our screen just to make sure that the screen is black while we're doing our drawing. We start the introduction music, which is a parody of the Operation Wolf music. And then we load in the pointer to our 4 animations. Then we get the X and Y coordinate of the animation we're going to show. We get the color, and we get the address of the quarter screen tile map. And we show that tile map to the screen. That's the first frame. We then fade in the correct color, loaded in into A. We wait a while. We get the address of the second tile map and show that tile map to the screen. Then we wait a while, and then we fade out. So that's the sequence, and we repeat that for all 4 stages of the animation, which is how we get the animation you saw before. So you can see here, there's the first 2 frames of animation, another 2 frames of animation there, there's another 2 there, and the final 2 there. And then once the animation is played, we play the Operation Suck sound effect. Now what we do is we do a far call to memory address 0, and this is in the second bank, and this is essentially running the show title image routine there. So that will show the title screen, and then to play the speech we do a high call, which is where we load in the second bank into memory address 8000 onwards, and we call 8006. And that is the play sample routine you can see here in that jump block. Now we'll have a look at those more in the next lesson, but what I want to discuss next is the way the palettes actually work. Now the game is of course 16 colors, and there are 4 possible palettes for the different 3D glasses types. You can see I'm cycling through them there. And so the first palette here is the black and white palette for 2D mode, and we've also got a black palette here just for when we're blacking out the screen. But then we've got a palette for red cyan mode, a palette for magenta green mode, a palette for blue yellow mode, and a palette for 2D mode. And the palette for 2D mode is a little bit special because we set the 4 colors that would make up the possible combinations of the 2 3D eyes, but we're basically disabling one of the eyes by palette switching. So you can see here that the 4 colors are set to the various shades of grey here, so that one of the eye is effectively disabled. Now that's used for the title screen. If I just press the 3D button here and switch to 2D mode, the 16 colours are still drawn there, but basically 12 of them are effectively neutered. The in-gameplay 2D mode is done differently. We actually disable the right eye drawing via self-modifying code to save some speed, but at the title screen that was the more appropriate way of doing it. Now the fade routines, basically what these do is these will load in the two possible fading palettes, the pink palette and the blue palette, or the two possible fading out palettes, the pink palette or the blue palette, and we can see those just here. These are actually 4 color palettes, so you can see the 16 colors here, but this is 4 stages of a 4 color palette fade. And so the way these are actually used is we actually use the same 4 colors 4 times to set all 16, and that was really just to save memory, to be honest. The set palette routine will basically look at the accumulator, and if the accumulator is set, it will switch the palettes over, selecting either the pink or the blue palette. And the reason we're using the accumulator there is for that introduction animation, because the introduction animation had a byte that defined which of the 2 palettes should be used. Now when we're using a 4 color palette, we're basically setting the first 4 colors and initializing the pointer to the palette, and then we are setting the next 4, and then the next 4, and then the next 4 here. So we're repeating that 4 times, and then we're delaying, and then we're repeating for the next stage of that fade. So we're doing those 4 colors first, and then we're moving down the line and doing the other 3. So we're doing that 4 times. Our set palette routines, well, these are storing the 3D palette, so this is the color type, and then we are multiplying the palette number by 16 and then selecting the offset, and this is selecting the 3D glasses type. And then if we're going to set 16 color palettes, we're going to loop this 16 times. If we're setting just 4, then we load in a 4 here. We're starting from palette 0 here, so we're loading that into C, and we are transferring 1 byte from the palette, and we are outing that to the palette registers there. So that's setting the colors. We're repeating that, setting all the colors for the palette. The 3D effect is done differently. The enabling and disabling of the 3D during the game, that's not a palette trick. That's actually a self-modifying code trick. And so what we do is here we are checking the 3D mode. Now, there are 3 possible depths that the game can use. So if I start the game here, and I turn back into 3D mode, there are 3 possible stereoscopic depths here between wide and off. So we can use those. Now basically we are here, you can see we are changing the 3D depth here, and if this depth is set to 0, we're enabling 2D mode. And the way we enable 2D mode is we put a C9, which is a return command, that's the byte for a return command, at the start of the show sprite R function, effectively disabling it. If we need to turn 3D mode back on, then what we do is we load in a byte from a backup and we write it to show sprite R. Now this is just a simple trick that I've done because we need to put the correct byte for the original command there. Well, what if I decide to change the command that's there? It's a bit of a pain to work that out every time. So instead what I've done here is I've at the start of the code loaded in the current byte that's there and written it to that backup. Now that wastes a little bit of memory at the start of the program, but it's a lot easier for maintaining the code. That's not something I did really with Chibi Akamas. There was a lot of self-modifying code in that, and it is a pain trying to work out all the byte code. You have to look it up in the manuals and things and get it right. If you make a mistake, the code doesn't work. So using a backup is a lot easier. So there we go. So that's really all we're going to be covering today. We're going to go over the rest of the code, including the remainder of the title, next time. As I said before, you can go to my website, you can download the source code and the game itself, and the source code is free to use in any way you wish. If you want to take parts of it and make your own commercial games out of it, I really don't mind. You're welcome to do so if you can. If you want to support my content, see more games come out, you're welcome to buy my book, Learn Multi-Platform Assembly with Chibi Akamas. It's available on Amazon. It covers Z86, 502, 68000, 8086 and ARMS, so please buy that if you want to support my content, or if you prefer, you can back me on Patreon over there. The patrons do get to give suggestions and feedback when I'm deciding what to do next year. If I'm not sure how to change things, I will ask them and make changes according to their recommendations. Anyway, I hope you've enjoyed this today. Thanks for watching and goodbye.